Good evening, ladies. I promised I was going to create the video for finding the area between two curves using definite integral. So let's start first by understanding how to get the area. So what area are we talking about? The area that we're talking about is the shaded region between the two curves. Do you see the two curves? The first curve is this one right here, which is the f of x, and the second curve is this one right here at the bottom. That is our g of x. Now, how do I write my setup or finding the area under the curve? So first thing I need to do is to write my integral symbol, and I am integrating from the lower boundary A to upper boundary B. What is A and B? That's going to be this one right here where the region started on the left side, and this one right here where the region ended on the right side. So these are our lower and upper boundaries. Sometimes the boundaries they're looking for is are the intersections of the two graphs. Now, after you've identified your lower and upper boundary, you want to set up your expression by subtracting the upper graph. The upper graph is the one that bounds the region above the curve. And the lower graph will be the graph that bounds the region below. Okay, so how do I write down my equation or my expression? That will be upper function. In this case, it's f of x, that is above, minus the lower function, which is g of x dx. Now, I wrote down several steps on solving the area between two curves, or just the general steps. So I want to go to the next page and I'll tell you what to do. Okay, so I sometimes refer to f of x or the upper function as upper graph and the g of x as the lower graph. Now, what do you do? What do you need to do? You set up the integral that represents the shaded region. This is the integral that we're talking about. And then you want to simplify the equation. If there are terms that you can combine, go ahead and combine them so that you have fewer terms to integrate. And then you integrate and solve for the area using definite integral. So let's try some examples. I'm going to go ahead and do this example, which is a free response question, and I'll tell you how they grade this problem, okay, or how they scored this problem. Okay, first thing is to look at the region. The region that is between the two curves is this part right here. Okay, now let's read the question because sometimes I don't read the questions as well, but I need to understand what's going on here. Let R be the region, that's our R right there, in the first quadrant, bounded by the graph of y equals 2 square root of x and the horizontal line and the y-axis, as shown in the figure above. Find the area of R. So where is the y-axis? Y-axis is going to be this line right here. And at that line, our x is 0. So our lower bound will be 0. And then this is our lower bound right here. That's our lower bound. I didn't mean to do that. Hold on. Our lower bound is 0. And then our upper bound will be the part where the two intersected, and that's right here. The x value there is 9. The y value is 6. Okay, so what are the other given? Y equals 6 is this line right here. And then 2 square root of x will be this curve right here. Now, if you take a look at the region, above the region is y equals 6 and below the region is 2 square root of x. So now let's set up our definite integral. Our lower boundary is 0, and we all go all the way to 9. So here we are already given with our lower boundary and upper boundary. And then we said the upper function is the line y equals 6. So I'm going to write that down first. That's my upper function minus the lower function, which is the 2 square root of x dx. Now, step 2, I said you want to simplify your expression. There's nothing I can combine here, but I can rewrite 2 square root of x. So when I rewrite that, I will keep my symbol or my notation 0 to 9. I am not integrating yet, so I'm just copying 6. minus 2x to the 1/2. This is so much easier to integrate compared to the square root of x. Now we can integrate. Square root of the integral of 6 is 6x. And then for the second term, it will be x to the 3/2 times 2/3. That's the same thing as x to the 3/2 divided by 3/2. And then we write down 0 to 9. Now we do upper boundary minus lower boundary. So for my upper boundary, I'll substitute the 9 to all the x's I see, minus 4 times 9 3/2 over 3. But my bottom substitution is just going to be both 0. 6 times 0 minus 4 times 0 to the 3/2 over 3. So the second group is actually 0. So I'm only going to deal with the first group. So let me write that over here. And I hope you can follow. 6 times 9, that is 54. Minus, how do I solve for 9 to the 3/2? When I'm dealing with an exponent that is a fraction, I first try to make the base smaller by taking the square root, because the 3 over 2 here means it is the square root of 9 raised to the 3rd power. So I'm going to take the square root of 9 first, and that will turn into a 3. But I have an exponent of 3, which is 3, so that turns into 27. So ends up being 4 times 27 over 3. Can I simplify 4 times 27 over 3? Yes, 27 over 3 can actually be reduced to 9. And now I can make substitutions or subtractions. 54 minus 4 times 9. If it's a free response, I can actually leave it this part at this part or at this part. You don't need to simplify it all the way. Okay? So this one right here is done. If this was a multiple choice question, your final answer will be 54 minus 36. And what is that? 54 minus 36 is 18. Let me check. Excuse my dog. She's playing. And yes, it's 18. If this was a multiple choice question. Okay? All right, so let's take a look at the second free response question. There are two questions here. Let me read the question first. Let R be the region in the first quadrant, again, enclosed by the graphs of f of x, 8x cubed, and g of x, which is sine pi x. Now, take a look at the graph and see if you're familiar with any of the graphs so that you can identify which is f of x and which is g of x. Now, let me take a look at sine for, or 8x cubed. What does 8x cubed look like if you graph? Well, the parent function of 8x cubed is a x to the cube power. Like this. X to the 3rd power. Now, 8 times x cubed is actually just stretching your graph vertically. So it's just going to grow faster compared to x cubed. But that's how the shape of the graph looks like. And then this one right here is our 8x cubed. Now, how can I tell that the other one is the sine pi x? Well, if you remember the graph of sine is 0 at 0, 0 at 0, and then it goes up like this, and then crosses 0, goes down at -1, and ends up here at its period. So how do I know what the period is? If you remember from pre-calc, period can be solved by looking at 2 pi over b. The b here is the coefficient of x, so it's going to be 2 pi over 2. Okay, so your period, one full cycle is equivalent to 1 pi, which is narrower than, it's not actually pi, I'm so sorry. That's 2 pi over b, and our b is pi. So our one full cycle is 2, okay? And if you look at the graph, that part right there is the sine of pi x. Okay, so now I know which one is my upper function, which one is my lower function. I can now use that information to find the area. But I forgot to look at the question, like I always do. You want to write an equation for the line tangent to the graph of f at x equals 1/2. When I'm asked to write the tangent line, I always put this one first as an annotation. I'm going to do, this means I need to use this formula. And it's a tangent line, so I need to find the slope. Now, at x equals 1/2, what is the value of its y? They actually gave us already the value of y because that is the intersection at x equals 1/2, comma 1. And that is going to be the intersection of both the curve. That means at 1/2, your f of x is 1. And at 1/2, your g of x is also 1. That's where they intersected. So that means this one is good, this one is good. The only thing I'm missing will be the slope. How can I find the slope? Slope can be found by finding the derivative of your f of x function because they asked for the graph of f. So I'm going to take the derivative of this, and that is 24x squared. Now I'm going to substitute the 1/2 that they gave us so we can find the value of the slope. So that's 24 times 1/2 squared, or 24 times 1/4, which is equal to 6. I need the tangent line equation, so that's just going to be y minus the y sub 1, that's 1. Your m is 6, and then x minus 1/2. Leave your final answer in this form because this is an equation of a line. Remember, there are a couple of equations for a linear function. We have the y equals mx plus b, and we have the standard form as well, by equals c. Okay, and then the point slope form, which is in the form that I just wrote over here. The simplest form that I can use is actually point slope form when I'm given a slope and a point. Now, off to the second question. Second question, let me erase this one. Oh, shoot me. Let me upload that one again. I lost it. Okay, there you go. Okay, now second question is B. Find the area. So we've already talked about the upper boundary and the lower boundary of our region. So I'm going to do the integral from 0 to 1/2. The upper function we said earlier was sine pi x. And then the lower function is the 8x cubed dx. Now I have to be careful because the second group or the second term is actually an easy integration problem. You're just going to use basic integration for that. But this one is u substitution. So I'm going to split the two into two integral symbols so I can solve for the u substitution in the first term and integrate the second term using basic integration. So let me split that. 0 to 1/2 sine pi x. I'm going to put the dx minus 0 to 1/2 8x cubed dx. Okay, now u substitution, I'll change my color into red. If I want to use u substitution, this will be my u right here. So on the side, I'm going to use this as my scratch. My u is pi x. The du is pi dx. But in my first integral symbol, there is no pi dx outside of the angle pi x. So I'm going to divide this by pi. And if it is a u substitution with boundaries, I have to change my lower and upper boundary as well. So my first lower boundary, original lower boundary was 0. Plug that into your u. So your new lower boundary is still 0. For my upper boundary, I have originally 1/2. I'm going to plug that into the u because everything is based on the u. Your du is based on the u. Your lower and upper boundaries are based on the u. So if I plug in 1/2 into the x of my u, I will get pi times 1/2 or pi over 2. I'm going to rewrite just the first integral into 0 to pi over 2. Sine of the angle now turns into a u, and then the dx is equivalent to du over pi. Be careful because pi is a constant, is a coefficient. You can actually factor that out, so it's not in my way, and then you can just go ahead and integrate this part. Okay, I'm going to continue this in the next page, but let me do the second integral here. 8x cubed is a polynomial, so you're just going to use the power rule here. Integrating that's 8x to the 4 over 4 from 0 to 1/2. I am using still 0 to 1/2 because I did not use u substitution in 8x cubed. And then I can substitute that in the next slide. Okay, minus 2x to the 4th from 0 to 1/2. Can I do this? Can I mix an integration and I've already integrated the second term? Yes, you can do this because they are not in a single integral solution. I needed to do this one independently from 8x cubed because I have to use u substitution in there. Okay, let me move to the next one. Let me see if I can move page or add a page. Okay, I wrote down what I had in the previous page. So I'm just going to integrate sine u du, and the integral for sine u du was or is negative cosine u, and then I will write down the boundaries to be 0 to pi over 2. Let me copy the second one, and I will integrate them and do substitution one at a time. So if I substitute pi over 2 to negative cosine, that will be negative cosine pi over 2 minus negative cosine of 0. So that became a plus sign because I had to subtract the lower substitution, so that's minus of the negative cosine of 0. Now for the second group, I will have 2 and x to the 4th, which is 1/2 to the 4th power, minus 0 to the 4th power. Okay, that is just going to give me a 0. So I'm going to clear this up a little bit and evaluate the trig functions. That's 1/2. Negative cosine pi over 2 is the same thing, or is coterminal with cosine 3 pi over 2, which is in the in between the third and the fourth quadrant. And the cosine there is 0. But the cosine of 0 is 1. So I can simplify both of that into 1 minus 2. 1/2 to the 4th power means I'm raising 1 to the 4th power and I'm raising 2 to the 4th power. So that's just 1 over 16 minus 0. Can I leave my answer like this? Of course. That one is already good. If it was a multiple choice question, then it becomes 1 over pi 1 over pi minus 1 over 8. But please do not waste your time trying to simplify some of your expression. As long as you have simplified the negative cosine pi over 2, evaluate that, and the cosine of 0, you'll be fine. And of course, 1/2 to the 4th power. They wanted to know if you know how to evaluate those. Okay, last example. I'm down here. It's a free response question also, and you are only asked to find the area of R. So let's take a look at the graph. Let R be the region bounded by the graphs of y equals sine pi x and a polynomial x cubed minus 4x as shown in the figure above. Find the area of R. Now let me study the graph first. For boundaries, where did they intersect? That's going to be this one, and this is the region that we want to solve. That's the region right there in between. The upper graph is obviously a sine function. I hope you are able to recognize what the graphs look like, okay, or just the general form of the graph, because sometimes they're not going to give you a graph. So I'm going to write down, I'll start from here so I'll have space. 0 to 2, upper function is sine pi x minus the lower function is x cubed minus 4x dx. Now it is important to put the second group inside a parenthesis because we want to subtract all of those terms. Okay, this is very important. Now I will check my first term has a sine pi x, so that means I have to use u substitution for that. But for the second group, I don't need u substitution. So I'm going to split that into two integral symbol. The first one, I'm going to do 0 to 2 of sine pi x, just like what we did earlier. And then the second one will be minus integral of 0 to 2 x cubed minus 4x dx. I will have to do a u substitution here, and then the second group will catch up later on. So if I want to do a u substitution, my u will be pi x, just like my previous example. The du is pi dx, but I don't see a pi dx here, only aside from the angle, which has a pi x. So we're not talking about that because the sine and the angle go together and they can't be separated unless it's an equation where we can move the sign to the other side of the equation, making it an inverse. Okay, I'm going to divide this by pi on both sides. I just did something that made my graph smaller. It's been a long time since I used this app, so bear with me. So dx is equal to pi over du over pi, and I have to change, of course, my lower bound and my upper bound. Originally, my lower bound was 0, but plug that over here. So that's pi times 0. It's just going to be 0 again. The upper bound started at 2. Now I'm going to plug that over here to x, and that will give me a pi times 2, or 2 pi. So I will evaluate the left side first. My boundaries are 0 to pi, or the first term. Then I will write that as sine u, but the dx is equivalent to du over pi. Don't forget that 1 over pi here is just a coefficient, so that can go outside. And now I can integrate sine u because it turned into a basic integration formula. Now let me have the second one catch up to my first one, because this I know how to integrate now. So if I'm going to integrate the second one, that will just be x to the fourth minus 4, x to the fourth over 4. I'm almost forgetting that. Minus 4x squared over 2 from 0 to 2. I kept the old boundaries because I did not use u substitution in the second group. So let me simplify that over here. X to the fourth over 4 minus 2x squared from 0 to 2. Okay, I'm going to write this in a clear space. Okay, let me continue this one. Now I'm going to integrate the first one, and the integral for sine u is negative cosine u. And I'll be plugging in 2 pi and 0. Minus, now I can actually do substitution in my second group. 2 to the fourth over 4 minus 2 times 2 squared. The second substitution is the bottom substitution, and that's just going to give me a 0. And the reason why I'm writing this out, even though I know it's going to turn into 0, is I want it to be a habit in case you forget that there are some functions that when you plug in the 0 for x, you don't end up getting a 0. For example, e to the x, if I plug in e to the x with 0 for x, that's e to the 0, and that turns into 1. Same thing for cosine. Cosine of 0 is not 0, but 1. So let us complete the first half. That's just, why did I put a negative sign? 1 over pi, and I'll subtract negative cosine 2 pi minus negative cosine of 0. And then I'll simplify this second term. This one is 2 to the 4th is 16 over 4 minus 2 squared is 4 times 2, that's 8, minus 0. Okay, that's just 0. Now I'm going to substitute or evaluate negative cosine of 2 pi. So where is 2 pi? This is 0 right here, and the ordered pair there is 1 comma 0. 2 pi is one complete cycle. That means 0 and 2 pi share a terminal side. We call that coterminal angle. So they actually also share an ordered pair, and that means negative 2 pi, which is actually a clockwise direction right there, is going to give me 1. Okay? Or negative of 2 pi is going to give me negative of 1. I didn't mean that to be counterclockwise. Sorry. I thought I was looking at the angle, but it is the trig function that's negative. So negative of positive 2 pi, negative cosine of positive 2 pi is negative 1. And cosine of 0 is actually positive 1. Okay, that turns out into 0. That means the 1 over pi is also multiplied to 0. So that's all gone right there. I'm left with 16 over 4, negative 16 over 4. That's 4 minus 8. And negative of negative 4 or positive 4. Can I leave my answer like this? Yes. Can I leave my answer like this? Yes. Okay, so these are our examples, and especially for those students who were not here the past few days, you want to do them on your own. Try to pause them and try it on your own, and then go back and play it, and then practice. I'm working even if it's after school, because that is how invested I am with your AP exam. And I hope that you are going to take advantage of the materials that I provide and the resources, including the videos that I make for you. So have a good evening, ladies, and I look forward to seeing you tomorrow.